The first four are probably the most common. Left, right, up, and down. You know all of those. Think about a parabola. The 2f of x and half f of x, those are some you know as well. Vertical stretch and shrink, it's like in Algebra 2 when you probably said like wide and skinny. So a 2 makes the graph really skinny, so that's considered a vertical stretch. That's the more technical, correct term to use. You might have used expand in Algebra 2, and that word's okay too. Vertical shrink or compress, either of those words are okay. So when we ask you what is the transformation, you can either say vertical shrink by a factor of 1/2 or compress by a factor of 1/2. Notice that when it's out in front, whatever that number is, that is going to be what is happening to the graph. So the same thing happens. You're multiplying the y's by 2, or multiplying the y's by a half, or a third, or -2, whatever it is. It's happening to the entire function. The other one that you've had before are the reflect over the x-axis. So all of these are ones that you have seen before, okay? Those are the most common ones. You started in Algebra 1 knowing those. Maybe you did some of that in geometry with shapes reflecting transformations. You did that in geometry. You did a little bit of that in actually probably 7th and 8th grade, moving things, 8th grade for sure. But the other ones you probably haven't seen before, okay? So the first two right there, the horizontal shrink and stretch by a factor of, notice it's the reciprocal of what's inside. So if it's f of 2x, okay, if we take whatever's in the parentheses or under the radical or inside the absolute value, whatever it is, you take the x values and you multiply them by the reciprocal of that. That's going to be the result. So if you plotted those points, the result of that is what would happen, and it's called a horizontal shrink or compress. Okay, either one of those words are fine. And then you say by a factor of the reciprocal. So notice the 1/2. That's a horizontal stretch, okay, because the x values are being multiplied by 2, so it's stretching, it's getting wider horizontally, or you're expanding it. So it's the reciprocal what's inside. If that was f of 3/4 x, then it would be a horizontal stretch by a factor of 4/3. Okay, it's the reciprocal, whatever that reciprocal it is. It doesn't have to be a whole number or a 1 over something. It can be anything. By 3/5, then it would be 5/3. Okay, so you take the reciprocal of that when it is inside the parentheses or under the radical or in the absolute value symbol, whatever that is. The other one is reflect over the y-axis. Okay, we've had some shapes look like that, like whether you reflect them over the x or the y, the result's the same. Okay, but not everything's like that. So reflect over the y-axis, basically what you're doing is you're making the x values negative. So if you look, we are doing the opposite to the x. If this reflects over the y-axis, then making the x's negative is going to reflect over the x-axis, because if we're changing the sign, if x equals 2 and we're making it -2, -2 is on the other side of the y-axis. Okay, so those are the two reflections, x or y-axis. And then these last two, probably you haven't ever seen those before. When you take the absolute value of a function, not an absolute value function, the absolute value of some function. So if I took the absolute value of x squared or 2x minus 3, something like that. If you take the absolute value of the whole function, okay, so if I have, this is the x-axis and this is the y-axis, and I'm taking the absolute value of the whole function. So here's the function. That means that the y values, no matter what I get y equals -3, then I take the absolute value of that, that makes it +3. So what this says right here, anything below the x-axis is reflected above it. So this is below the x-axis. If it's above the x-axis, it's already there. So that stays, but that green is reflected. It's not moved, okay? This green triangle down here gets reflected up, so it looks like that. That's what would happen in that reflection right there. Anything below the x-axis gets reflected above it. So if it's already above, it stays. If it's not above, it gets reflected up. Okay, so that's what that would look like. And there's really no short way to say it. Anything below the x-axis is reflected above it. It's not like left 2, right 4, up 6. Not that easy. Okay, you just have to explain it. And then the last one, if we just take the absolute value of the x's only, okay, you could say this a couple different ways. You like to use left and right of y-axis, or you like to use the quadrants. You can say quadrant 2 and 3, anything to the left of the x-axis. Okay, so let's say we have that shape right there. Okay, anything to the left of the y-axis is erased. So that is erased. And then what we do is we take what's on the right and reflect it over. It stays. So what's on the right still stays there. But that shape, whatever's on the right, is just reflected over. So that we have something that looks like that. And again, the reason, let's think about that. If I have x equals, let's say this is x equals 2. The result is -3. If I say x equals -2, the absolute value of -2 is 2, so the same thing is going to happen every time. You want to say anything in quadrants 2 and 3 is erased, and quadrants 1 and 4 are reflected over. Another way to say that. You like to use quadrants, you like to use left and right of the y-axis. Okay, so those are those two things. And we're going to do this, it's going to be piecewise functions, but you don't have to come up with the piecewise function. It's just going to be a picture of a function. And we're just going to do the transformations. So again, those are, you have to stay with those. You're going to have to remember them. Okay, all of them for sure for the next unit, but a lot of them for the exponent unit coming up as well, and logs. All right, so here's the graph that's given to you. Okay, that table is just the list of coordinate points, so I'm just plotting those points. Some people like to use the points, some like to use the parent function. Some of you can just go plot the points and you know what to do. I'll show you a couple different ways. But again, the table of values, that's just to kind of establish the points, and then it's a lot easier to move if you establish points that are on the graph. Obviously that graph is made up of more points than just those, 2, 4, 6. Okay, that whole graph has a ton of points in it. Okay, but those are just nice whole numbers that we have listed. All right, so what we're going to do first is, again, I just rewrote, you have this at the top of your page. It's just here on everyone so that you can see it up here as well as on your paper. What I like to do is draw the parent function or the given function really lightly on my paper. Okay, so that's what I did up here. Really lightly, I put that original function on. And now we're going to transform this. So it says write the transformations and then sketch the new graph. Okay, so f of x plus 2, that transformation is going to be left 2. Okay, so if we're writing it down, that's what we're doing. So we take the original function and move it left 2. If you like to work from a table of values, what happens to x or y? X is left and right, y is up and down. So I would be subtracting 2 from each of the x values, and those would be my new coordinate points. So if you like using the table of values and what happens to the x or the y, then do that. But you could just draw your new graph on the paper. You can see that in your head. You don't have to write anything down. Again, I like doing this very lightly. Be sure if you do write both of them that you one is just like, I can barely see it, or you need to label which one is which, or color code it. Something so that I know the difference. You can't just have two graphs on one coordinate plane and me know which one is your answer. All right, so what we do is we just take these dots, and that's why I think it's easy to lightly draw the original function, because then I can just take this dot, move it left 2, this dot, left 2, left 2, left 2, left 2, and left 2, and then just reconnect the dots. So there is my new function. Okay. You do not ever have to draw the original function. You don't have to come up with a table of values. All I want to see is the answer. But if you need to put them both, then do that. That's just one way to help you do it a little bit better if these are tricky for you. Now, the left, right, up, and down, those might not be that tough. But when we get to the other ones, it might be something that you want to do. All right, the 2 on the outside. So notice the difference between number 1. X plus 2 is on the inside. Now it's on the outside. So outside means we are moving up 2. Up affects the y, so our new coordinates are all the y values just get moved up. The x values, nothing changes to them. They stay the same. But the y values are all moved up 2. Or if we just use our graph, this is at 1, we move it up to 2. -1 goes up to 1. 2 up to 4. 1 up to 3. 3 up to 5. And 0 goes up to 2. And again, we should have the same exact shape as we started with. It's just being moved up 2. Again, those are transformations you've been dealing with since probably 8th grade at least. So those should be the easy ones. All right, now the 1/2 inside the parentheses. So being affected to the x. So remember, it's the reciprocal. So that means we're going to multiply something by the reciprocal, which is 2. And it deals with the x, which is the horizontal. So this is considered a horizontal. It's going to be stretch, because the numbers are getting bigger. So stretch or expand. The other option is compress or shrink. When it's in the parentheses, it's something different. So it's the reciprocal. So horizontal stretch by a factor of 2. Horizontal stretch by a factor of 2. So what that means as far as our table, if you like the table, we are multiplying all the x values by 2. Okay, if you like looking at the table, that's what happens. If you just want to go off the original graph, okay, just go to the first point. And since it's a horizontal stretch, we're at -2. The y values are all going to stay the same. We're at -2 times 2 is -4. We're at -1 times 2 is -2. 0 times 2, 0. 1 times 2, 2. 2 times 2, 4. 3 times 2, 6. So you can see the horizontal stretch or expand by a factor of 2. So really what this is, it's a 5-part piecewise. We can't come up with all of those lines right now. I wouldn't ask you to do that either. It's just a function that's given, not necessarily the function, the equation given, just the picture is given, and you just need to transform it. All right, so now this is the difference. Now the 2 is on the outside. So if the 2 is on the outside, everything stays the same. It's going to affect the function. The function are the y values. So we're going to multiply the y values by 2. So they're going to be multiplied by 2. So they're going to get stretched. So it's a vertical stretch by a factor of 2. Okay, vertical stretch by a factor of 2. So when it's on the outside, it stays the same. What that means as far as the table goes, all the y values get multiplied by 2. So now we're looking at the y value. The y value is -1. We're going to multiply by, 1. We're going to multiply by 2. We get to 2. -1 times 2, -2. 2 times 2, 4. 1 times 2, 2. 3 times 2, 6. 0 times 2, so that stays there. So, see, you have a vertical stretch. If it was above the x-axis, it goes higher. If it was below the x-axis, it goes lower. So it is vertically stretched, again, by a factor of 2. Very important to list that by a factor of. All right, negative x. This is the one that's maybe a little bit new to you. We really haven't, especially in this class, we haven't ever reflected over the y-axis. We've always reflected over the x-axis. So when it's in, it's a reflect over the y-axis. So if we reflect over the y-axis, Okay, here's the y-axis. If we reflect over the y-axis, that means the x values are changing. Okay, y doesn't mean y change and x means x change. It's the opposite. If we reflect over the y-axis, the y value stays the same, but the x value switches. So all the x values, 0 obviously stays 0, are being multiplied by -1. They're reflecting over the y-axis. So I'm concerned about the x's. So if x equals -2 and we multiply -2 times negative, we get +2. -1 reflects over to +1. 0 stays 0. 1 goes to -1. 2 goes to -2. And 3 goes to -3. So the shape that was on the right should be on the left now. The shape that was on the left should be on the right, because we're reflecting over the y-axis, and that's when the x is negative. If the function is negative, that means we are reflecting the y values, so that's a reflect over the x-axis. If we're reflecting over the x-axis, the y values are the opposite. Something goes from the top to the bottom, the y values change their sign. So now we're concerned about the y's. We're at 1, we go down to -1. -1 goes up to 1. 2, down to -2. 1, down to -1. 3, down to -3, 0, stays 0. So there's your shape. And so you should see a mirror image across the x-axis now. And again, that is one that we have done many, many times, even in this class this year. Reflect over the x-axis. That's the most common one that you've seen. Reflect over the y-axis, not as common. Haven't done it in here. But the x-axis we have. Questions so far? All right, now the absolute value ones. So these, you just have to memorize those transformations, okay? Because it's not as easy just to kind of think about what happened. So you can think about, I'm going to explain to you what's being done. So the absolute value of the function. So you get a value for y, but then you take the absolute value of it. So no matter what value you get for y, once you take the absolute value, that makes it positive. If you do a bunch of work and you get y equals 10, the value is 10. But if you do whatever the function is, if it was a function that we had an equation to and you got y equals -2, once we took the absolute value of that, it would be +2. So that's why anything below the x-axis gets reflected above it. Okay, anything below the x-axis gets reflected above it. So again, that's just in your list of transformations down there. So anything above stays. So this is going to stay, this is going to stay, stay. All that's going to stay. But we have this green that's below. So that little triangle is going to get reflected above. Not just the dot. Okay, we don't just put the dot up here and be done. This whole picture gets reflected up. So it's like a mirror image. So that's blue is your answer. Anything below the x-axis is reflected above it. Now, could this ever end up below the y-axis, x-axis? Of course, because we could say the absolute value of f of x minus 5. And then we take that and we bring it down 5 units. So it could end up below, but not necessarily. You could move this left and right. You could do all kinds of things to it as well. Right now we're just doing one thing at a time, but you can do more than one transformation at a time. All right, and then the absolute value of x. So we're taking the function, but only taking the absolute value of x. So this is the one that's kind of wordy. Anything to the right of the y-axis, sorry, the left, or we can think of it as quadrants 2 and 3, however you like to think of that, is erased. So that goes away, that whole side goes away. It's gone. And then we take anything on the right, so the right stays. So that's part of the graph. And then anything on the right, or in quadrant 1 and 2, get reflected over. He is awesome. So we just take this picture and reflect it over. So just come down here, up here, and down. And there's your graph. So that's kind of why I like to not use the table of values. Table of values of the original function, fine, but it doesn't really make sense to me if we try to figure out a table of values to graph this. It's a lot easier, I think, to go off the parent function, or the given function, whatever that is, not necessarily parent, but take the given function and apply those transformations to that. Okay, that's the way that I think it's the easiest. It's not the only way. Don't have to ever see the parent of the given function, but I just think it's the easiest to do that. And if you think about this, no matter what value I put in for x, whether I put in a 2 or a negative 2, if I put in a 2, my result's going to be whatever the function is with a 2. If I put in a negative 2 for x, I first have to take the absolute value of that, which is 2, and I get the same value. So no matter what value I'm at 1, the y value is the same. I'm at 2, the y value is the same. I'm at 3, the y value is the same, because I'm taking the absolute value of x. So no matter what I put in for x, whether it's positive or negative, my result is going to be the same y value. So that's why that happens. And again, we could move this left and right, up and down. All of that could happen as well. Reflect it, could have a negative out in front, and then that picture gets reflected over the x-axis. Okay, all of those things could happen as well. All right, so that's just one transformation at a time. Again, I'll put this back up so that you can recopy it down if you haven't, or take a picture, whatever you need to do so that you can memorize that. This is just reminding you about transformations. Transformations must happen in the order of operations, which is PEMDAS. You do what's in the parentheses first, then you do exponents, which we won't have. We get to the exponent log unit, we'll have exponent. Then you do multiply and divide, then you do add and subtract. Okay, so very important to follow those order of operations when you are listing. Okay, if we ask you to list them, they must be listed in order. If you graph it, you have to graph it in order. If not, you're going to have an incorrect graph. So this first one, there's nothing to do in the parentheses because it's just an x. So then we do multiply, divide, so reflect over the x-axis, then up 8. Okay, so reflect over the x-axis, then you go up 8 on that one. Number 10, parentheses first. So write 4. It's the opposite when you're adding and subtracting in the parentheses. So write 4, then that would be considered a vertical shrink, or compress, whichever word you like better, by a factor of 1/2. Then we can add and subtract by 9. So up 9. So write 4, vertical shrink by a factor of 1/2, or you can say compress by 1/2 if you like that word better, if that makes more sense to you. Then up 9. All right, number 11 is a little wordy one. Okay, you just got to list all those words if we ask for what it is. So when it's the absolute value around the whole function, okay, that just means anything below the x-axis is reflected above it. Then we move that down 4. Below the x-axis is reflected above it, then down 4. Because parentheses, absolute value symbol, radical, all of those would be in the category of parentheses, grouping symbol. If something is a grouping symbol, parentheses is a grouping symbol, absolute value is a grouping symbol, radical is a grouping symbol. It groups things together. That's going to always come with the parentheses. All right, and then this last one, the middle step is a little kind of, you can do a couple different things. You have to do this first in the parentheses. So remember, that's the reciprocal one. So it deals with the x, which is the horizontal axis. So it's going to be the reciprocal. So 3, that means it's going to get bigger. So it's going to be a horizontal stretch or an expand by a factor of 3. Then we do the multiply and divide. So -4. We can do that in 2 steps or in 1. And really these 2 steps could be flip-flopped because we could multiply by -1 and then 4, or 4 and then -1, or -4 together. Doesn't matter. So one way is we could say a vertical stretch by a factor of 4 and then a reflect over the x-axis, or we could flip-flop those. Or if you just told me a vertical stretch by a factor of -4, that contains those two together. And then down 10. So these right here could be flip-flopped, or they could be put together by saying a vertical stretch by a factor of -4. Okay? Because the -4, both of those are multiplied. -1 and 4 are both being multiplied. So you can flip-flop those or put them together as one transformation as a vertical stretch by a factor of -4. Because the -4, the negative takes care of the reflect over the x-axis. So again, just important to know the order of operations because we've added a lot more. Before, it didn't matter all the time. There was just like every once in a while when we had a move up and down and a reflect, it mattered. But now we've added twice as many reflections, so very important that you follow that order of operations. Okay? So again, there are all of those. If you don't have them down, take a picture, whatever, I don't care. Just be sure that you know them because you're going to have to know them for this unit and the next unit, and most of them for the log and exponential unit. Not all these down at the bottom, but the next unit 10 is just functions part 2, and we have a different type of function we're dealing with, and those transformations you are still going to need to know them. All right. So again, you'll get your quizzes back. I have not even started grading them yet, but they will be done this weekend, and you will get them back on Monday. And on Monday also, I'm going to try to come to all my classes at least for a little bit, so if you have questions, especially on the quiz, like what you did wrong, anything like that, so you have me here to answer some of your questions. I'm going to try to make it clear for you. But again, I'll be in the mezzanine if at any time during the day you do have any